I haven't been speaking that much for the last 2, 3 years, and mostly because I thought I didn't have anything to say. And I started looking back at what I've been doing for the last few years, and a couple of things started emerging that I realized I was doing, and some of it accidental. But I've been trying to distill it, and so I've been trying. Probably will start talking a bit more about that. And so this isn't a lecture to tell you, oh, this is the next great thing, and you should try this. But rather for me to use you to have conversations and get your thoughts. And so your critical view of what I'm talking about will be highly appreciated. So please bear that in mind. I'm looking for feedback. Some of these things that I'm talking about, all of these things I'm talking about has been through work that I've been doing. So anyway, is it okay if I drink beer while I talk? All right? Okay, cool. Right, so Douglas Adams, anyone knows Douglas Adams, Hitchhiker's Guide? You live and learn, and at any rate you live. So some of us, that's what we're trying not to do, right? Just live and just exist, but to learn and get better at what we're doing. Okay. So I've been thinking about what we actually do in the act of building software. And so there's a problem at one side, we have conversations, we design something, we write the code, and then we run it, and people use it. Hopefully they use it, right? And it's a very, very simplified view of the world. But largely, it's those 5 things. Nothing more, nothing less. And we have come up with ingenious ways to do this. And we still struggle at doing it. And we can argue that code is design and design is code and all of those things, and we can get incredibly philosophical about it, and probably rightfully so. But largely, it breaks down into 2 parts. There's a part where we're trying to understand what the problem is and how to fashion a solution. Comes with us applying that understanding. And so there's that 2 distinct parts, and one deals with the problem space and one deals with the solution space. So we try to do this, and then we try to apply that. And we know the old story about, well, you should spend a lot more time trying to understand, otherwise you'll just build the wrong things. And we also know, and have been in enough projects and building products where at some point you'll stand up and say, well, I never knew that was the reality. It took me by surprise. And so for many years I used to say that your code is just one requirement away from being invalidated. Just one. And so trying to understand is probably the paramount to applying your understanding. Weak understanding, weak application. That's generally what happens. We know this is better when we start putting feedback in, right? And it says that, well, depending on how it's used, how we've built it, let's be wary of that. Let's observe what is going on, and then try to do it better. Okay. Whatever those observations may be, whether you are writing tests or anything else, we have learned over the years that it's better to have this kind of feedback loop. And then people will go around and say, well, you can get certified and it's called Scrum and all sorts of other things, but let's not go there, right? This is about trying to understand complexity. We also do this, which is just fix the mistakes. And because we do make mistakes, it's not deliberate. No one wakes up in the morning and says, today I'm really going to stuff it up, and go home and tell your family, how was your day, Dad? Well, you have no idea the mistakes I put into production today. It was amazing. We had a lot of fun doing that. So nobody does that deliberately. Often the mistakes come in because either we're tired, there's a slight blip in our life, and we make a mistake. It happens. With as much test coverage you can have, we still make mistakes. Sometimes it's weird combinations of data that we never thought of. Like, whoa, when did that happen? Sometimes it's timing. I didn't expect that to happen when that happens. And it's pretty weird. you know that story. It never happens on my machine, you know, but it happens there. So we fix mistakes, right? Some people just write queries in production. But largely, when I think about it, there are two very different kinds of complexity we're dealing with. This early part where we're trying to understand, it's dominated by the complexity of the domain, the problem that we're trying to solve. The other part where we build these feedback loops, there's a complexity that's attached to change. How do I bring in the change to an existing design? How do I know how? And that's really, really hard, right? Like, you've learned something new, but you have to accommodate that in existing work. It's great when you're writing software that's never gotten to production, but the day it goes into production is the day it's legacy, right? Because you have to change it. And that part is hard. And that requires a different set of tools of how you deal with change than how you deal with the inherent complexity of the domain. And so that's what I call the nature of complexity. One part is about inherent complexity. It just exists permanently in your domain. It's not going to go away. And so the responsibility is on us to try to crack open that inherent complexity, understand it in the best way possible, and find the appropriate solutions to make it work. The other one is what I call insidious complexity. And insidious means it's gradual and it's generally very harmful. That is, you take your eyes off, it sneaks up on you over months and years and iterations and sprints, and it bites you in the backside, and it's like, I didn't expect that to happen. But it was coming along anyway. So one is dealing with permanent complexity that is part of the domain is very different from, like, I'm writing code here, but I got to keep my eye out there because things are happening that I didn't expect. And then we call it code rot and entropy and all sorts of wonderful words stolen from other disciplines to explain that insidious nature of change. So, when we're dealing with inherent complexity, our understanding is low. Our degree of ignorance is incredibly high. And our job is to become enlightened in the domain. Not in the world, in domain. Low understanding, we're trying to increase our understanding, reduce our ignorance. And so here we need tools for learning. On the other side, where there's this insidious complexity that comes from change and feedback, we need tools for adapting. It's different. And so let's make sure, that's my thinking, that we're using the right tools in the right place. And so what do we have at the moment? So if we look at inherent complexity and the tools that we generally would use at our disposal, you guys are familiar with domain-driven design? Who isn't? Show of hands. Okay, a little bit. So one of the things in domain-driven design is this notion of concept of ubiquitous language, which means we should all understand the vocabulary of the domain, and it should be consistently used throughout our work, from conversations down to code. And so if I call it a customer, let's call it a customer throughout. Don't suddenly say client or person or company or something like that. Let's be consistent. So ubiquitous language is one thing that we use all the way from conversation to code. We use patterns, gang of 4 patterns, domain-driven design patterns, any other patterns that we find useful to solve that particular problem. We also use test-driven development, TDD. We also do a lot of refactoring. And that generally becomes the de facto tool set of a developer working on any kind of project that's trying to work in an adaptive or iterative way, in general. And in some bars, they frown upon you if you don't use those things. Okay, so not necessarily that's what we want to do. But that's the tool set we've become comfortable with. You want to sit up here? Sorry. You want to grab a seat up there? Yeah. It's absolutely fine. If you can sweep past. Right. On the other side, when we're dealing with adapting to the change, the complexity of that, we still use patterns, we use TDD, we use refactoring, we still have the ubiquitous language, and more recently you call it DevOps, but largely it comes down to continuous delivery, continuous integration, continuous delivery. It is get the changes into named environments, preferably production, as frequently as possible so you can actually deal with that sooner. That's the tool sets that we use to deal with change. There may be one or two others, but that's what dominates our toolbox. So what do you notice? In our attempt to deal with complexity, it's thin on either side of design and code. It's pretty damn thin. On one side, we've got ubiquitous language, which we're trying to get better and better at. On the other side, we've got continuous delivery, which takes us into a run environment. But largely, we're struggling on the other side. And here, how often have you sat and worked and then figured out, but we're solving the wrong problem? We've done a lot of work, and then you realize, like, bloody hell, it's the wrong problem. Because we asked the wrong questions, right? So now you gotta go all the way back. And I don't care how agile you are, you have to go back if your understanding is screwed up. If you ask the wrong questions, you will build the wrong things. But a lot of our effort goes in that middle section. That's where we play. Yet there's complexity that flanks it. That's a bit thin in our toolbox. We just have quite a few empty spaces there. Now, I'm not saying that we shouldn't do what we do at the moment. For very, very good reasons, we actually do need to give that attention and that rich tool set to making sure design and code actually works out as best as possible. So I'm not saying ignore that. I'm not saying stop doing it. We have to do that. But I also believe that we should be doing a bit more. And that's what I want to talk about, is tools for code. That's what it comes down to. And code is the ultimate representation of your design. It's tools for code. But what about how do we break down a problem? How do we understand that? How do we deal with better conversations, and how do we deal with that weird place at the end where code goes to live or die? What do we do there? And yet those are important parts, because you don't figure out the part at the end between code and run. Look where the feedback loops emanate from. And here's the problem on this side, and get that wrong, it's a disaster. So let's pause for a minute. So that's the problem I'm trying to apply myself to. Okay. And I spent a lot of time with TDD and DDD and all of those things and spoken about it, and yet I think that I always end up feeling, how come my projects suck each time, right? There's always a moment where it just sucks, right? And I used to blame the project, but actually it's the complexity that sucks, right? And I just am really bad at it. That's the fact. It's like, don't kid yourself. Enough patterns and books out there, and you still find a way to mess it up. Okay, this is a customer that I've been working with for a while. I've simplified it, but it's good enough for now. So it's a company that offers loans. They're amongst the top 5 in the market in which they play. Okay, so it's loans, personal loans or finance, vehicle finance loans, but they offer loans. Okay, so you need some money, you need to buy something, you go to them, you apply for a loan. If they think you're in good financial standing and you're not an exposed political perp or something like that, you'll get a loan, right? So they're amongst the top 5 in a large market. They want to be number 1, but what they say is that it takes too long to approve the loan applications. So someone applies, I walk in, by the time they approve to say, hey, Aslam, we're happy to give you a loan, it takes too long.
By then I've got answers from everyone. And when I go to a financial advisor, they're talking to everyone in the top 5 and the top 10. So they feel that they're actually taking too long. And they think they're taking too long because the workflow to process an application is far too rigid. How many people here work in large enterprises? Banks, insurance, telcos, things like that. Everyone else is in a startup. Wow. Okay. Anyone heard that the workflow sucks? Anyone here said, oh, we need better workflow? No. Right, so that's what they say. And as good software developers, when we see things like it takes too long to approve, workflow is rigid, we'll start doing things like that. Okay, let's map out the workflow. Let's find out what's going on. What are the different scenarios that play out through this workflow process? And then we should visualize the value stream. Where's the waste? And where's actual work being done? And then we want to know what is making it slow. And those are all legitimate questions. They're absolutely legitimate. But let's take a step back. Let's look again. What they actually want is to be number one. Remember I was talking about the wrong problem? They want to be number one. But they're saying that it takes too long and it's too rigid. So, given they want to be number one, do they or us, the software developers, fundamentally believe that we can get to number one by fixing that? Make it faster and make the workflow more flexible. And if it did those two things, you would become number one. And here's the difference. When we look at that through a very specific lens of outputs and inputs, being number one is the output, what they want. Too long to approve, rigid workflow is an input. It somehow may or may not translate to not being number one. But where we should be focusing on is the output. And so that's the first thing that I've learned. You focus on the output. And they say they want to be number one, but cut out the speculation, cut out the emotion, actually use data to help you establish where you are at the moment. The data exists. It's there. And so when we look at the output and we say, where are you at the moment? And if we just simplify this to say that up on that axis is the number of loans, and then at different stages, there's a lot of applications, loan applications that come in, huge drop off to it being approved, and then even though we've approved it, some people just say, no, I don't want it, and they go to a competitor. So we see those two slopes, and it's a problem. So that's what the reality is at the moment. And at the back of the head, our mind, we're saying, is it workflow? Is it inflexible? Is it taking too long? And if I fix those, will it change the shape of the curve? So that's your current status. That's what the reality is at the moment. And you use actual data to visualize this. You must use actual data. Make the effort. As part of that early stage to deal with inherent complexity, visualize it with real data as it exists. Don't guess, don't assume. Your conversations with people change when you pull this out and put it on the table and say, sorry, fact. Fact. This particular client, they gave us the data. We produced pictures that looked like this, went into a further conversation, and arguing against this, and I said, but it's your data. And then it was, no, it's not. I said, no, it is your data. This is the source, this is what it looks like. Given what you understand of your output, what do you wish it to be? Do you want to approve more loans? That is, stop rejecting that many? And if you approve more loans, are you going to increase your risk? Am I going to lend someone money who probably can't pay us back? So what do we want to do? Lift the number of approved loans? Or do we want people to accept the loans that we've approved? What are we trying to solve for? Again, what's the complexity we're after? So the inherent complexity here is to be, number one, we need to change something, we don't know what yet, while not increasing the risk to unacceptable levels. The question is, what must we change? Right, so let's pause right there. What did we just do? By focusing on the output, using actual data, we surface the inherent complexity with far greater clarity. Data is wonderful. Visualize it, you can talk to it. It's much easier than waving your arms in the air and saying, no, we need to run faster and we need to scale. So, tools for code. Right here at the beginning, we can do output-based modeling with data. And this is what I found over the last few years. Every single time I'm in a conversation, if I switch the conversation from, hey, what is the output that we want? The conversation changes. Because once you figure out the output, then you can figure out what are the inputs that actually have a material effect on that output. Worst thing is not knowing the output. The less worst thing is knowing the output and choosing the wrong variables that actually don't shift the dial. So figure it out. The answer's in the data. So, we've gotten this far. We're going to shift from here to here. The question is this statement. Still takes too long, rigid workflow. Let's explore that. Okay. Is it legitimate? Is it sentimental? Is it emotional? Let's figure that one out. So we're still playing in this part, right? Trying to understand. Okay? So it says it takes too long because it's a rigid workflow. Question is, takes too long, is that a genuine observation or is it a bias? Did someone just say, oh, it takes too long? Right. And that rigid workflow, is it an assumption or is it fact? So one of the things we want to do is challenge assumptions and biases. We've been in enough teams, sat around enough tables, on whiteboards, the people says, no, it really is like that. How do you know? Well, I just got this feeling that it is like that, and therefore it must be like that. And then we design based on that, right? So the answer is genuinely, again, in data. We can challenge that with data. So, takes too long is a bias. It's based on an assumption of rigid workflow. The observation by working with people is that there's a lot of manual processing. Why? Because there's a high rate of exceptions. Loan applications come in, we don't know how to deal with that systematically, programmatically, system-wide, and therefore it's an exceptional case, and therefore it ends up being manual processing. And the reason why it ends up in manual processing is because we're too scared to give the loan in case we give loans to people who can't fulfill it. So it's an entire business built on fear. But that becomes a bias because you will have real data, and we found the real data that actually shows there's a high degree of exceptions in the workflow process. A lot of rejections that could be resolved. So this is the assumed reality tree. That is the one that's the genuine current reality tree. So we thought it takes too long because of rigid workflow. We found a lot of manual processing because of high rate of exceptions. The reality is that we approve less than we can, and that's truth from data, because of a fear of incurring risk, because we saw that there's lots of manual processing. We genuinely measured high rate of exceptions. And one more thing. Why is there high rate of exceptions? Inconsistent data coming in on the loan application. And so the workflow rules cannot process the inconsistent data. So truth from data, observation or inference, and truth. That's the current reality tree, not a feeling on this side. Given what you understand as reality, what do you actually want? because you want to shift this tree to that tree. And that's what we call a future reality tree. That is, we want to increase approvals through automated processing and have a low rate of exceptions by having consistent loan data. That's what we're after. Now notice how we started about we want to be number one and workflow's bad and it's rigid and it takes too long. And this is genuinely the process we went through over a few weeks and a few months of working with them. And had we rushed out and started building a new workflow and had business analysts and testers and all sorts of people swarming around us with wonderful swim lanes and sub-processes and things, we wouldn't have gotten to this. It would not have fixed bad data coming in. The only thing that would have happened probably was that the new workflow would also have high rate of exceptions and still suck. Let's pause there. We want to use data to challenge biases and assumptions. We surface a current reality tree, and we want to hypothesize about a future reality tree. It's a hypothesis. It's all it is. It's a wish. It's what we believe. But it's fashioned on fact based on data. That's the difference. This, I'll mention, this current reality tree and future reality tree comes from the body of work around theory of constraints. So if you dig around that, around thinking tools for theory of constraints, you'll find stuff around that. There's a few good books out there on that. Yeah.
You're familiar with the 5 whys?
Yes.
Seems quite similar as well.
Yes, you are popular in the why stack. Yeah. The variation I do that is that sometimes it gets a bit stale. It's like, oh, here you go, Aslam, 5 whys again. It's like, you just ask, so what?
Yeah.
It's the same thing, right? It's like, so what? So what?
You can sort of
Yes.
write the future.
Yeah.
Yeah.
We're getting better. Current value tree is based on data, hypothesizing a future value tree. You can't do the current value tree, you have no right to propose a future value tree. You can't produce a current value tree based on fact, modeled with data. Don't go the other way. You're back in the land of speculation. Right, so this is a hypothesis now. You still want to achieve that, but we're getting better. We believe we can increase the number of approvals by increasing the quality of the loan data, reducing the number of exceptions that cause manual processing, etc. It's getting sharper, it's getting clearer, getting to know what we want to do. The question then is that how do you know we're trending in the right direction? Imagine we did build something. How do you know it's getting better? So we want to be able to do that, so we need it to be measurable. We're looking for feedback, but we want to be very precise about that feedback. We want to be able to measure the right things. This is what we know so far. We know we need to increase the quality of the data, and what we're trying to see is a decrease in the number of exceptions. If we decrease the exceptions, approvals go up. We bring more approvals to customers quicker. So, if we change something here, we measure the impact on that side. That's what we're after. What do we change? Sometimes the process is not trivial. Sometimes it's the result of 15 years of great ideas. And sometimes only one person in the building knows what the true workflow is and how the process really works. So given a complex flow, complexity like that, existing systems, existing things, where do you introduce the change? Because you want to play with the quality of data and you want to measure somewhere what's happened to the exceptions. Now imagine if I said you can measure with a thermometer. Where do I place the thermometer in this picture? And I said, well, you can adjust something here, but where do you do the adjustment? It's crazy, right? And trying to see it in that way is just insane. Good luck. And don't say we'll do it everywhere and it's a big data problem. So pull right back out. Find the significant parts and just ring fence it. There's a part we know, we don't have to go into the detail, we know that part deals with receiving an application, this part deals with assessing, that part makes an offer, and that part signs a loan agreement. In the DDD world, you might say that those could be potentially bounded contexts. Potentially. My experience is that they really become good candidates for bounded contexts because it's a nice cohesive thing. I can wrap this up. There's a nice boundary, the national contract here, here, and here. But if I'm dealing with it at that level, it's less daunting. And so I can say, the loan application data is a bit of a mess. I only want to introduce changes here. Only here. And I want to reduce the number of points at which I can bring about changes. Try to keep it to one, if possible. But don't sprinkle it everywhere, because you run into that whole concurrency thing, and it's just too much to deal with. And then measure at appropriate points. Don't measure everywhere. Measure at meaningful points. You'll get it wrong. You might choose the wrong places to measure, but you'll find out very quickly because you'll ask yourself, doesn't make sense. Why isn't the data looking the way I thought it would? So measure here, 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 and here. Here's the trick. Once you know what to measure and where to change, again, visualize it. Here we're trying to measure the number of exceptions. So in this bucket, that bucket, that bucket, and that bucket, I want to know what's the shape of exceptions. This one here seems to be quite gradual. This one has a steep drop-off. This one is quite high and a sudden drop-off, and that one is pretty flat. So we want to be able to watch this. Every time I write code and I put it in production, I want to see this. Genuinely want to see this. I want to visualize this all the time. And so changes that I make that affect the quality, I might have come up with a great idea. We can do this, and that'll increase the quality. We'll do an OCR thing for that part. Is it genuinely shifting this? Or is it not? Is it changing in a way that we didn't anticipate? And so that's the feedback that you're after. You don't know if this is the exact shape that you want, but you're after a trend, okay? What we're actually doing is that we're using heuristics. It's loosely defined, and we want to get better and better based on feedback. So we want to be able to use heuristic-based thinking and heuristic-based experiments based on hypothesis to establish whether we're trending in the right direction. That's what we're after. So it might be horrible to start off with, but based on what we see and what we change, we want to anticipate something getting better. So we actually go into a learning loop when we work in this way. So, on the run side, build in heuristic feedback loops. That allows you to manage that insidious complexity. Because if you've got your eye on the ball, and it's telling you that the changes that you made, as opposed to going through and saying, well, what's the next story we need to play in this iteration, build in that instrumentation very early on, and start seeing whether that story actually has a meaningful impact on the business. Now that does not solve code rot, but what it will give you, to some, it contributes to it, it influences it, because you're going to make changes in the right place. You're not going to make sweeping changes across your code base because of one story or some idea that you have. You want to try something out and then turn on the tap a little bit faster and then see if it will still hold. So, we dealt with that, dealt with that. On that end, we're using data to design heuristic-based feedback loops. What do we have at the moment? Inherent complexity, model the output with real data. Establish a current reality tree using real data. Pop the 5 whys. Don't just ask it qualitatively though, back it up with data. Hypothesize the future reality tree. That is what you want. Once you've created a hypothesis, design the feedback loop. If you use heuristics, you stand a better chance of being able to learn and adjust and shift with the changes as you go along. It's logic. There's a few other tools along, but that's the four that come to surface quite strongly in the work that I've done in the last few years. So this is what we notice. Really good with code, flank it with data. Kind of forgotten about that. The moment we move from entity relationship diagrams to object orientation and domain-driven design, and they're like, no, data's bad. Data's our friend. Contains truth. Let's get better at data. We're getting better and better and better at code. We need to get better and better and better at data. Not designing data structures, but working with the actual values and fashioning a story based on the values. You can even argue that even if you're writing the code, you figure out the data structures right and your algorithms and computations get simplified. So there's a strong theme here of going data first. Right. I have a suspicion. This is what I'm working on at the moment. So I can't say it's true. It's a suspicion, and I am testing it. This here is a classification problem. That's a recommendation problem. When I'm playing with data here, I need to be able to classify the use cases. It's a loan for a customer that's single and just finished university. It's a loan for someone who's working for 5 years and about to get married. It's a loan for a business with 2 shareholders. It's a loan for a family trust, and that's held by 2 adults and a person who's under 18 and will come of age and be a full member later. I want to be able to classify that. And when I classify it, I can start doing more interesting things. Because then the workflow doesn't become a workflow, it becomes a suggestion of what potentially could be the process to follow if I classify it. Recommendation here is based on what you see that comes through the system. You'll notice certain events. Oh, I saw that, therefore I can recommend that. The risk profile that we are using for that classification is actually too high. What we're finding is that single people who just finished university are actually higher risk for the following reasons. People that earn over this amount in that sector are higher risk. So I'm going to suggest a risk profile based on what we've learned. I have a suspicion that most of these break down into those 2 classes of problems. I know people are saying, oh, it's AI and stuff. I'm not on an AI bandwagon. But it's interesting. And the challenge why I'm struggling with is finding the right seed data. And I don't have enough use cases yet to say that is why it's a suspicion. What is being tested is this. Do you know how we measure progress on a project on software? Before Agile, it was a Gantt chart with Microsoft Project or something, right? And the milestones were there, and everyone was over-allocated. And then Agile software development came along, and then it was burn down charts or burn up charts or something like that, and then some Jira-based thing or whatever, right? So, but at the end of the day, it was still progress based on work done, effort. What are we doing on this client? Working with the chief operating officer, progress is measured by how is this shifting with each release. And we were releasing frequently. We'd love to release more frequently, but at the moment we can only accommodate releasing once a month. So we want to measure this. This is progress. This is progress on the impact the software is having on the problem. This is what you want to measure. Are you getting to number one? Not, is the software complete and no one uses it? Anecdotally, in this project, right at the beginning, someone said, well, we'll get to number one if we have a mobile app that someone could apply a loan from. It's like, that's app envy. It's not going to make sense. And most of your loans coming through brokers. So, good luck. But this kind of thing suddenly gives you the data, the facts, the ammunition to actually prioritize better. You suddenly can play a story that you've analyzed or want to play based on an anticipation of how it's going to shift that. When you get that kind of thinking in your organization, the nature of how you build software changes, because you're not chasing that sprint review, that showcase, that big demo, and you know you've curated and fudged some data to get it through, right? So it's that kind of situation. So why am I harping on data first? This is what I've known. Over 20 odd years of building software, the moment you talk about software, it's this imaginary thing that no one really can describe. It will do this amazing thing, and then you start drawing a user interface, and that's the closest they can get to understanding what the software will do, right? But when you make data visible, the software suddenly becomes tangible. You're not talking about software, you're talking about the impact of the software. I can take this and we're going to make it look like that. This is what will happen. And that's what we want to do. We want software that makes an impact. We want it to be used and must do something interesting. We can make better decisions based on facts. The key to that is interpretation. Like they say, you can make stats tell you anything, right? Statistics, I can make you tell whatever I want it to be. So, criticize the interpretation given the raw data. That bit in the middle, internal consistency of truth, I learned from a lawyer. He said, it's easy to find people guilty because there isn't a consistency in lies. The amount of effort you have to go through to create a consistency in lies is huge. But the natural consistency of truth is trivial and easy. Because if you lied and you said you were here instead of there, then you need someone else to corroborate that, etc., etc., etc. To be able to tame complexity, if you are able to tell the story of the domain with data, it's a fantastic feeling. It's an absolutely fantastic feeling. You're able to play it out like that. You can point to things and say, it does this here, it does that there, that's what happens, and then that happens, based on data. So, live and learn, any way to live. Right now I'm trying to live with telling stories with data. And that's helping me deal with this whole complexity sucks thing. So, thank you.